but each of the concepts we talk about could obviously be follow-on topics if anyone is interested, either one-on-one or in follow-up webinars. And we'll have a questionnaire at the end that'll be sent out if anyone wants to go deeper into any of these topics. So one of the things that's interesting about AI is that it's not just a technology shift, although it is that, and there's a lot of really interesting tech that is manifesting in companies and offerings by various companies. The real phenomenon is that even though the algorithms that people think of as machine learning, neural networks, and support vector machines, and a lot of the random forest and regression type algorithms have been around for decades. Some of them even go back as far as the 1930s and 1940s. Over the last 5 or 10 years or so, many of them suddenly started working. And there's a couple of reasons for this. One is that there was some innovation from a computer science perspective in the algorithms themselves. So more layers and deep neural networks, techniques like backpropagation started to get some improvements to them. The big change, though, was that the volume of data that was available to train models and the power of the computing infrastructure that was available to do the training and the inference improved by many orders of magnitude. And as a result, things that even the most optimistic practitioners in the space thought were going to take decades, beating humans at Go, being able to compose music, certain types of video and image recognition have been essentially solved to the degree where the computers are able to dramatically outperform humans in many of those tasks. The tasks are still pretty narrow, but many of them have manifested themselves as companies, and the investment in those companies has started to pick up. This is pretty similar to the curve that you see with any new overhyped technology. And with overhyping comes, in this case, what we call AI theater, right? So over the last 6 months or so, we haven't seen a single prospect, I'm exaggerating slightly, but not much, that doesn't claim to be using AI in some way, even when they're not. There is an old joke that says that AI is what you call something in the technology space until you can do it, and then it's just called software. And there is a little bit of that going on, but the core tech does have some special attributes to it. So the nature of the machine learning models that are powering many of these AI systems is about making predictions and recognizing patterns in data. And there is a broader, more ambitious goal of having machines be able to create analogies and understand language and be able to take ideas from one domain to another domain. And they can't do any of those things. And it's actually not clear that that will happen anytime soon. It would require another fundamental computer science development, which is not impossible, but these are the kinds of things that happen every couple of decades. And so it's hard to predict when that would happen, if it happens at all over our lifetimes. But what is happening is there is kind of an old model in the software industry where humans would show up at work every day and write software, and then the software could do something like process loans or manage fraud detection. But what's happening now is the machines are at work and the machines are writing the software, and then the software does something. That's an oversimplification, but the idea is that data comes in and then the machines have models that get trained, and those models then become software that can then take action or make a prediction. And people don't call it machines writing software, they call it machine learning models being trained. But it's the same basic idea. And this is on the right-hand side of this page, you see a toy example around fraud detection, where you have a model and then there's data that comes in and it trains the model. And then there's a couple of layers of different kinds of data that are involved. And the data sources in AI and machine learning are actually important to understand because they speak not just to how to build a system, but where are the sustainable sources of economic power for a business. And so what are the moats that you can have if you're a business that's powered by AI in some way? So 3 types of data that are involved in the process. The first is training data. This is, I think, what most people think of when they think of data. Data is the new oil, or machine learning models needing data in order to be good. And this is the corpus of historical data So if you're an insurance company, it could be a couple of decades worth of insurance claims and images of damaged vehicles and information about how much it costs to repair the vehicle. And those can get feed into the machine learning model and create the initial parameters, which are essentially large numbers of numbers that tune the system and help create the prediction. The second type of data is inference data. This is, or sometimes called input data. So once the model is there and the predictions are taking place, so a machine is doing predictions whether we should repair or replace this bumper in a vehicle, each new instance of data that comes in is called input data. Every time you do a Google search query, right, that's input data into the system. The model is already trained, but there's also an instance of data that's coming in that the machine then will take action against or make a prediction against. That's also a very important source of data, and it's often in a different place. So you might have the ability to purchase training data, but inference data really needs you to have an operational system of some kind that interacts with customers in order for you to have access to it. So sometimes there are different companies that have access to those two different data sources. And then the third kind, which is also important, is feedback data. And this is information, if you make a prediction as a machine learning system, it's information about how accurate that prediction was. Were you correct? Did it work? And then you feed that back into the system and you continue to train it. Not necessarily in real time. You can batch up the data and release a new version of the model. For example, in Tesla's autonomous driving capabilities, every time something happens in any vehicle, that data gets sent to Tesla. The models are not updated in real time. They're batched up. They're brought together to train a new version of the car, and then they're released every certain period of time. You know, it could be as long as a week or a month at a time, and so it can be tested and people can make sure that it works. Important source of data if you want to have a model that continues to improve over time. One way to think about it that I like, which is laid out in a couple of different things, including some academic work and Harvard Business Review paper and a new book called Prediction Machines by a few Canadian economists, is to think of what's happening from an economic perspective as the cost of prediction decreasing. And it's very similar to what happened with other technologies that were ingredients in pretty much every business, like electricity or transportation, or even something like light. When those technologies decrease in price, we're used to in technology prices continuously decreasing, even though prices overall in the economy tend to increase slightly over time. There's usually somewhere low single-digit percentage of inflation in a relatively stable economy, but in technology there's massive deflation, huge decreases in prices in most domains. And when the cost of something like prediction goes down, there is a concept of an economic complement with an E. And an economic complement is something whose value goes up when the cost of something that is complementary to it goes down. And in this case, an example of a complement to prediction is human judgment, right? So most systems or businesses or processes involve a combination of prediction and human judgment. And human judgment is a little bit of a nuanced concept, but the idea is that if you have a process like declining something as a result of fraud, it's not just a question of predicting whether or not the thing is fraudulent. Someone at the credit card company needs to figure out how the entire organization is affected when a transaction is denied. What's the impact on your brand? How much lost revenue is there? How much risk can you absorb with respect to a customer switching card providers? This is different for high net worth individuals who may be your card members and regular card members. And the machines can't do any of that. What they can do is predict the likeliness of a specific transaction being fraudulent. And so that sense of complementarity is really interesting as people start to go through their business processes and rethink areas where they may be able to add a prediction machine. And it also has implications for the boundaries of a firm. Like what makes sense to be an entity? Should you vertically integrate more? Should you have more capabilities to have access to more data? Maybe you should deconsolidate and outsource more functions because now you can predict better, and therefore you can have contracts with external parties because things are more predictable that previously you had to do in-house because you needed to manage the people who were doing it because you couldn't predict accurately enough. There's a couple of different types of machine learning that are powering these AI systems today that are working well. This is not an exhaustive list, but it's a pretty good list of functions that are working that manifest in many use cases. So one is text anything related to text analysis and generation. You probably noticed that voice to text in your cell phone has improved dramatically. It used to be almost entirely inaccurate. Now it's still inaccurate, but it works, and you can make minor tweaks to something that you say into your phone. Language translation, Google Translate is actually getting quite good. The ability to generate text, there's examples of machines writing poetry and things like that. Anything related to image recognition and video recognition, so recognizing faces, recognizing objects in videos, tagging videos with what's taking place in them, even generating realistic pictures of people who don't exist. Anything that has to do with anomaly detection, so deviation from the norm analysis, it's sometimes called, which is, this is a baseline. We invested in a cybersecurity company called Darktrace, which is a network. It's basically put it on network span ports. It watches all network traffic. It doesn't understand the network traffic, but it develops a sense of self within the enterprise, and it starts to realize what's normal and this is me. And then if something foreign comes in, like a cybersecurity attack, then it says, this is foreign, this is not normal, and it doesn't understand very much about what it is, but it can quarantine it. It has a product called Antigena that can create antibodies that sort of defend against that, and then it can share antibodies between customers, so you get sort of a herd immunity. So that's an example of an application of the anomaly detection capability. And then nearest neighbor, this is probably the machine learning capability that's most familiar to people. This is a class of system called support vector machines so recommendation engines use this. This is something like LinkedIn people you may know, or Amazon product recommendations. But these capabilities can take the form of a huge number of different real-world applications and systems and functions that are, some of which are very magical. I mean, this is a very small sampling of the things that have come online being powered by AI and machine learning over the last few years. And many of these are actually from our own portfolio companies, right? Detect payment fraud is something that we invested in a company called Sif Science. Analyze legal documents, we invested in Kira Systems, which is machine learning for understanding contracts, which look and feel very much like code, but have historically been very hard for machines to understand. They're kind of hard for humans to understand too, but they're very structured, so well suited to machine learning. The pre-caching streaming TV content, that's something that Netflix does. So in addition to just recommending shows that you might want to watch, it will guess which shows you're likely to watch and then take the data from those shows and put them on the edge of the network near your TV, so that if you decide to watch them, you experience a higher degree of responsiveness. One of the things that's interesting about that is you can imagine that as prediction continues to improve in accuracy and decrease in cost, there are kind of new fundamental business models that may be possible. So like one example, if you take the Netflix concept of pre-caching TV content, which is very inexpensive, so you can do that even when your prediction is only 90% accurate or 80% accurate, because worst case scenario, you just get rid of the cache. But something like Amazon product shipping, you need the accuracy to be better, right? If you only have 80% accuracy and you ship products to people and they're before they've even ordered them, and they have to return them 20% of the time, that's a hassle, they'll get annoyed, it's not a good experience. But if the accuracy goes up to 99.9%, all of a sudden it starts to become pretty interesting to just ship things to people and then maybe pay for the process of letting them return it if they don't like the product. And that can allow you to do things like rethink the entire value chain in an industry or a set of industries in the case of retail, including maybe you want to own your last mile delivery. You want to build out a return infrastructure. And so that's the kind of thing that's taking place across a variety of different domains, which is the price of prediction is decreasing and things that were fundamental constraints or bottlenecks in the value chain and an ecosystem are going down. or changing, and that is allowing people to rethink the boundaries of firms, and many industries themselves can be transformed. And a lot of products and offerings only exist because of the fundamental difficulty associated with prediction. And when prediction goes away as a constraint, then all of a sudden certain things that like airport lounges, which rely on the fact that it's hard to predict how long it will take to get to the airport. If you can get more accurate in your predictions, some of those products just don't need to exist at all. One error on this page I just wanted to point out is distinguishing chihuahuas and muffins is actually not a thing that the machine learning systems can do yet. That's a fundamental computer science challenge that has not yet been solved. So there's a number of limitations. This is just a small sampling of some of the things that are hard about machine learning and AI today. But one is that the data is hard to get and is often bad. So it's scattered in various places, often poorly labeled. It's hard to extract for privacy and legal and technical reasons. A lot of times it's just wrong. A lot of data that's stored in systems is just not accurate. So this is just a problem that's hard when you're trying to train models using data. If you can't get to the data, then it often doesn't work as well as you'd like. Explainability is another important challenge. So this is the idea that if a machine learning model can't show its work and tell you how it came to a decision, that's fine in some areas. So for example, if you're blocking email spam and some spam gets through and you want to understand why did that get through and not something else, but you can't because it's being trained by, the model is trained by a deep neural network that just looks like a huge string of random numbers. That's fine. You don't really need to know why it made the decision, right? It's not a big deal. But if it's something like making a loan decision, like are you going to provide somebody with a loan, then it's not okay for the machine to say, I don't know how I made the decision. It's just a random string of numbers. You need to actually be able to understand it because there are actually legal reasons, like legal rules about what ingredients you're allowed to have in a decision, which factors you're allowed to include. And in many cases where there may not be legal reasons, there's still ethical or moral reasons, like autonomous driving. You need to be able to understand. So there are some types of machine learning, Bayesian networks, which craft causal diagrams and allow you to see the reasons behind a decision. Decision trees, of course, have that quality to them. But many of the more popular machine learning systems, like deep neural networks and support vector machines, don't have very good explainability. So that's a challenge today. Privacy, which is front and center, is another obstacle. So in general, businesses want to treat data carefully from a privacy perspective, and yet still leverage it in training machine learning models to produce better products for customers. Obviously, there are some companies that are bad actors and actually don't care about privacy at all, or don't care about it enough. But it's actually a hard technical challenge. And if you're Facebook, you can hire tens of thousands of people to work on privacy problems. But your typical business, your healthcare company or your education business can't do that. And so there needs to be a world of technology vendors that help to solve this privacy challenge to make sure that data is treated carefully. And that's still in its early days, very much at like pre-venture even. It's hard to make venture bets even at that level because the companies don't exist yet, but they will. And then operationalization is another challenge, which is you need to be able to take the system. If you make a prediction, that's great. You can show the prediction to someone. But it's even better if you can take the prediction and operationalize it and have the system actually do something with automation. And the automation itself can involve a prediction machine. Then there's various autonomous vehicles and robots and things that are coming online to leverage machine learning and AI. But today, most of the machine learning systems are making a few predictions and then showing those predictions to a human who then does the action. But operationalization will be an important piece of as people take the AI systems and bring them from industry to industry and change the way various businesses are done. This is going to be a big part of it. Is attaching automation to the predictions. I wanted to go through just how Insight thinks of investing in this space, and this is a huge oversimplification, this 3-layer framework that I'll go through like any framework, but it gives you a sense of where we see the more and less attractive layers to invest today. The first layer is what we've been calling base platforms. And these are toolkits or workbenches, systems that you use to build an AI system on top of. So they don't do anything themselves other than allow you to build a machine learning system. And in general, investing at this layer is really hard. And the reason is because the best technology in the base platform layer is actually being built in-house by large consumer internet companies like Facebook and Google, and they made available as open source projects for free that get better very quickly, or made available via public cloud platforms like Amazon Web Services, SageMaker, for extremely low price points that get cheaper all the time and get better really quickly. So if you have a startup or a growth stage business and your business model is to charge money for a platform that's not as good as TensorFlow coming out of Google, let's say, that's free and getting better really quickly, that's a tough business model. It's not impossible, right? So there are examples of successes. We invested in a company called Alteryx that was essentially at this layer. They IPO'd last year. We just recently invested in a company called Sisense that has a nicely integrated platform for data ingest and warehousing and dashboarding and analytics and machine learning. But we just a much higher bar, right? So you need to see really clear evidence of technology differentiation and other sources of economic power around talent and brand, and demonstrated quantitative evidence of traction in the market. The next layer, layer two, is much easier. And this, we've been really active at this layer. So these are cross-industry applications. So systems software that does something right out of the box, but that are applicable across industries. So it's not just healthcare or education. It works across all industries, and where the system is a learning system. So it gets powered by more data and it gets better over time, and where the system is hungry for more and more data, and so it continues to improve. It doesn't finish. It never is like done, which is actually an important item to diligence in general in AI investments, which is that in some areas you have flat or increasing returns to incremental data, and in some areas you have rapidly diminishing marginal returns to incremental data. When there's rapidly diminishing marginal returns to data, it's still probably a thing you should do. Like, you should have the machine learning system because you can make better predictions, but it doesn't give you any economic power the way Google has with search, right? Google search has actually at least linear, if not increasing returns to incremental data. As you do more searches, the system continues to improve. And that's what you want to see if you're going to think of the machine learning data access as a source of like an economic moat that will last for a long time, ideally decades. So examples of cross-industry capabilities, fraud detection is one. This is working surprisingly well. So these numbers, they may not seem as impressive on the screen because, if you go from 10% to 5% number of orders held for manual review, it doesn't seem game-changing. But if you do something like go from 5% false negative to 1% false negative, less than 1%, that can completely categorically change the nature of the system, right? You can go from, just making recommendations to humans to taking humans out of the loop in most cases and only having them get involved when there's an error or an exception. You start out by having the machines check the humans, and then eventually you can have the humans check the machines, and then the humans just have to handle very small numbers of exceptions. Cybersecurity is probably the best example of layer two. We've made half a dozen AI-powered cybersecurity investments already. The really nice thing, cybersecurity is an important thing in general, and so huge secular growth opportunity from a investment perspective. There's real businesses that are substantive. The legacy players, the large publicly traded companies that do cybersecurity, are mostly in secular decline. So they've curated investor bases that want them to return capital, and they're no longer allowed to do things except kind of wind down and raise prices on customers and fire employees. So that creates a good macro backdrop for growth stage businesses with really powerful technology. And so we've invested in almost every functional area in the cybersecurity stack in either the best or in the top two companies in the area, in the domain. And we try to invest in the the machine learning version of the thing. So Cylance, for example, is a endpoint, essentially antivirus product, but instead of looking for signatures of known viruses, it creates a sense of understanding of what is a bad actor behavior like, and then looks for that. And then as soon as it sees an attack like the WannaCry attack that happened recently, it will then immediately notify all the other customers. And so you get this kind of herd immunity. So customers, it's not just that these become better businesses when they get to scale, the customers benefit from them as well. So it's not just better investments, but as a customer, you want to bet on the system that's going to get better the most quickly. And because you benefit from the improvement of the product. And we even see behavior like customers will advocate the product to other customers for you because they want to get the benefit of the improvement. And there's a number of these. So Darktrace, as I mentioned, is another. Recorded Future uses machine learning and AI for dark web monitoring. And Tenable, which IPO'd earlier this year, has really powerful vulnerability management capabilities. And so the great thing about this business is the customers are happy to give you all the data. They want you to treat it carefully. It's obviously very sensitive data, but it's not their core business. Their cybersecurity information is not the business that an insurance company is in or a healthcare company. And so therefore you can build a business you still have to get to scale, and there's a lot of operational challenges around that. I mean, this is the thing that Insight is very good at, is helping companies scale. So it's nice if they have a strategy whereby if they get to scale, they can have a huge long-term advantage. And then the third layer becomes somewhat challenging again. And so we've been cautious, although we've been making some interesting investments here as well. These are turnkey industry-specific applications that use AI to power the system. So this is education offerings or financial services specific offerings like loan origination. One example of an investment we made recently is a company called Tractable, which is sells to insurance companies and it has a deep learning based system that can use images of damaged vehicles to do a better job of estimating how much it'll cost to repair or replace the part than the best human claims adjusters who have been doing this for decades, based almost entirely on a photo and a little bit of structured claims data that come in. And so the challenge in a business like this is something that becomes important during diligence, right, is that if you approach a customer, if you're Tractable and you go to a large insurance company, you say, why don't you give me all of your claims data so that I can build a software business with huge amounts of economic power? The first reaction will be, well, we want to try to do it ourselves first, right? We want to, because otherwise, what are we going to do, right? Are we just become a customer relationship management entity or like a hollow shell? And so there's a set of tasks you need to do to engender comfort that there's still a lot of high value things for you to do, even if we build the power around the machine learning system as a vendor. And actually you benefit from getting on the platform that's going to win in the space because you get all the information about all the other claims that are coming through, not just your own internal systems. Also, it's going to be very hard for you to do this because you're not going to be able to attract the machine learning talent. It'll take you years. And by then, your competitors will be using the system that will be getting better the most quickly. And so one of the things we look for in diligence, in addition to understanding, are there increasing returns to data, what's the curvature of the model training like, is have they cracked that nut, right? Have they been able to convince the customers to not just give them money for the software, but give them access to the data and the spigot of fresh data that's coming in? Tractable has, but a few others that we've invested in, like Precision Lender and Kira, have as well. But it's a pretty high bar. So it's similar to layer one in that we're making investments, but we're pretty cautious at this layer. In financial services, there's a lot of use cases that we're seeing. A lot of them have to do with pulling in signals, just the volume of signals that are out in the world about what might be good investments or how are investments doing are often too much for humans to manage and handle. So it's well suited to a prediction machine. Monitoring fraud, compliance, and cybersecurity is another popular set of use cases in the financial services. The prediction machines can power interesting new product areas, so new offerings that were not really feasible or realistic before because the cost of prediction, when it was done entirely by humans and wasn't super accurate, it was too high. And then you can also reduce expenses. There's a lot of automation, right? So there are many steps where the task could be automated except for the prediction step. And now that the prediction step can be handled by a machine learning system, it's possible to automate the whole task. And that can be pretty transformative. I mean, just in a non-financial services example, Amazon has warehouses. They're almost entirely automated, right? So that if you look at them, the shelves are moving around on wheels and bringing the objects to the humans. And the one step that isn't automated is the ability to take the item off the shelf and put it into the box. It's called picking. Picking is really hard for computers because it's very easy for humans, but very hard for computers. And there's a contest every year called the Picking Challenge, which gives prize money to the people who make the most developments in robotics and machine learning to improve picking. But it doesn't look like it's going to be solved anytime soon, maybe decades. And so that last mile, that last step, means that the whole task can't be automated. But there are other tasks where everything has been automated except for the prediction step, which is done by humans today. And so in those cases, adding a machine learning system can cause the whole process to be automated. And then probably most interesting is just challenging the idea of what is the current boundary of the firm, right? So what do we outsource? Where do we want to think about vertically integrating or other capabilities that we want to have in-house to give us access to data that will represent sustainable economic power? And I think most entities are not thinking about this enough. It actually can become a good catalyst for strategic thinking, not just about what's going to happen to the industry, but also where can we gain an edge over competition. We're actually, we have built our own first machine learning system for internal use at Insight. We did a project first to look to see if we could purchase anything in the space, and nothing existed. So this is not uncommon, right? There's actually very little in the sort of a growth stage software business that's big enough to be able to bet your business on them, because you don't want to bet on a venture-backed company in many cases, because that they may not be 9 out of 10 companies fail, that kind of thing. And then the grown-up companies, the sort of declining publicly traded companies, haven't really been able to build things for about 5 or 10 years, and so you have to find a growth stage business that has the function that you need, and in most domains it just doesn't exist yet. So we ended up spending a couple $1 million to build this internally, and it's a system based on AWS. It pulls the data in from a huge number of feeds, both internally and externally, and it's used just for one small sub-function within sourcing. And so sourcing is an important function sorry about that. Sourcing is an important function in the in Insight, competitive differentiation for Insight, and the sourcing team talks to tens of thousands of companies a year. We have a database with over 78,000 companies in it. We have a tremendous amount of data, not just at a point in time, but time series data over many years about companies. We also pay for a lot of data sources. And the goal of this machine learning system for sourcing, which pulls in all those data and signals into a data platform in AWS and uses some open source and closed source machine learning frameworks to build a learning system, and then feed that into Salesforce, which is what the sourcing team uses as their system of record, is just trying to find signals of companies that might be good and growing rapidly. And then there's a feedback system where if we make an investment and it ends up working out nicely, or if the company is really growing, then that can be signaled back to it and it can improve over time. And the goal this is not intended to actually start to reach out to the companies or make investment decisions or anything even remotely like that. It's just trying to handle this very narrow prediction task around identifying companies that might be growing rapidly. And that it's actually early indications are very positive. We just put it into production recently. But this is the kind of thing that as a financial services entity, if you sort of look across your enterprise and try to pick out tasks that are taking place that involve prediction, you can find discrete tasks like this that you can swap in a prediction machine and make dramatic improvements. With that, I will open it up for questions.
That's great. Thanks, Lonnie. As a reminder to everyone, so we've allowed some time here for questions at the end, so feel free to add some questions to the dialogue box on the right. We've had a few questions come in already, so I'm going to start with those. Lonnie, first question. We've heard a lot years ago about the concept of big data. What's the difference between big data and AI?
Yeah, it's interesting. So big data, which as a phrase is already sounding extremely stale. So if you put that into your product name or your company name, you're